It's about that time. I still need to clean up yesterday. It was pretty... I mean, I just kind of slapped it in. So, how can I, like... How can I, like, This is kind of a common thing. Let's see. Dude. I don't like this. Yeah, I can't make like a utility method for that, or else I'd have to pass all four of those things anyway. I can make like one in here. So the only difference between these two is one uses a like a visited set. Look at that. This is exactly the same. I could like pull this out into like a little method or something. What would I call it? I would have to pass. One, two. I would have to pass 4 arguments. I mean, that's not too bad. Whatever. Is valid. What I call that is yeah, this whole thing basically. I'm gonna call that I2, and I'm gonna call this J2, and this will be I1 and J1. Is valid next point. IJ neighbor row, neighbor column, and then up here it'll look like this. IJ neighbor row, neighbor column, and let's do this. Visited not equal null, and then I can just pass null. Yeah, that's what I'll do, I guess. Score sum 2. Yeah, these would be the same. Well, score sum. What are we doing? It was like distinct hiking trails. Count all trails. If we're counting all trails, just pass null to DFS. We'll just say count I'm gonna flip it. Count distinct. I'll flip it. And then we don't need this. Whoa. Change this to just DFS. Yeah, DFS. And then score sum for part 2. We are not counting distinct, but for the first part we are. There we go. Make sure that still works. Oh, it didn't. Null pointer. Oh. Did I flip it? To the sample? Because it should be 36 and 81. Oh, 0. What the heck? Oh. What? Oh, how did that get there? Oh. Visited is equal to null. There we go. Boom. Yeah, yesterday's was nice and easy. I hope today's easy too. It's day 11 though, man. I made it to day 12 last year. It's day 11. Day 11, baby. Well. Sweet. I wonder what today is gonna be. Got 8 minutes. What was it last year? What was day 11 last year? I did it. Hot Springs. Like day 10 last year was something about lava, was it not? Oh, no. I thought it was. Oh, I'm thinking of day 12. Day 12 was like something about lava, right? Day 12. Oh, no. Yeah, day 11. Dang, I keep clicking on the wrong one. The sum of the lengths of the shortest path between every pair of galaxies. Oh my gosh. The universe expanded in the time it took light from those galaxies to reach the observatory. Only some space expands. Oh, I remember doing this one. Yeah, I literally just made my thing bigger. I remember doing this. Oh, I do remember this one. I brute forced it. I think I brute forced this one, right? Oh my gosh. That is, each empty row should be replaced with 1,000,000 empty rows. Each column should be replaced with 1,000,000 empty columns. Or did I? I don't remember exactly how I did this one. I mean, I could look. Day 11. The universe, man. Oh my gosh, look at this. Oh, I had like a main in there and everything. Goodness gracious. Yeah, I was just brute forcing it. Oh boy. Look at me just saying array list here on the left side. So just this one song, that's no copyright? I guess, dude. Are Christmas songs even copyrighted? Okay, this says no copyright. You hear that, YouTube? No, it's not enough. I need more. Well, you have more? This is copyright free. But YouTube, like, whatever AI they use to, like, screen the videos, I guess, it just hears me say copyright. Watch, this will be blocked. Watch it. Maybe I should have to say, no copyright. No, it's not copyright. Wait, this doesn't, yeah, copyright free. YouTube, you hear that? It's gonna block it. I already know it will. How loud is that? It's not like loud, right? That's good, right? I think I'm kind of loud. Check, check. One minute. Each spoon. Uno minuto. Oh wait, this looks like a number 10 or something. Is this like the 10th year in a row? Ah, okay, that makes sense. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I had to count them. It's the number 10. I see it now. I'm ready, boy. All right, let's go. Here we go. I'm actually going to turn the music off, though, because it's probably going to freaking block it. Here we actually go. The ancient civilization on Pluto was known for its ability to manipulate space-time, and while the historians explore their infinite corridors, you've noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Sometimes the number engraved on the stone changes. Other times the stone might split in two, causing all other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first applicable rule in this list. If the stone is engraved with the number 0, it is replaced by a stone engraved with the number 1. If a stone is engraved with the number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the new left stone, and the right half of the digits are engraved on the new right stone. If there's an even number of digits in that stone engraving, the new numbers don't keep extra leading zeros. Right. Okay, yeah. If none of the other rules apply, the stone is replaced by a new stone. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on the new stone. No matter how the stones change, their order is preserved, and they stay on their perfectly straight line. How will the stones evolve if you keep blinking at them? You take note of the number engraved on each stone in the line, your puzzle input. If you have an arrangement of 5 stones engraved with the numbers like this, you blink once. The stones transform as follows. The first stone 0 becomes marked with 1. Okay, if a stone is engraved with the number 0, it's replaced by 1. That's the first rule. The second stone is a 1. Yeah, none of the other rules apply, so it turns into 2024. The third stone has an even number of digits, so it's going to get split into 2 stones. Fourth stone, same thing. This stone gets multiplied by 2024. So after blinking, your 5 stones look like, become an arrangement of 7 stones that look like this. Here's a longer example. Initial arrangement looks like this. After 1 blink, 2 blink, 3 blink, 4 blink, 5 blink, 6 blink. In this example, after blinking 6 times, you would have 22 stones. After blinking 25 times, you'd have a bunch of them. With this arrangement right here. This is my input. In this example, after blinking 6 times, you would have 22 stones. After blinking 25 times, 25 times. How many stones will you have after blinking 25 times? So I'm going to use, what am I going to use here? I think it would be best to use like a linked list here, just for like the speed. Wait, it's like, yeah, array list is implemented with an array, so I'll use like a linked list, since like adding the new elements in between here will be faster. Yeah, right. I guess I don't think it really matters. Let's just worry about the rules though. So here's the rules. Let's do it. So we basically just need to iterate through. We just need to iterate through our stones and apply the rules. Yeah. Easy enough. What would be like the cleanest way to like, because I have to like split stones into 2 sometimes. If I iterate through with like a for loop. Well, I could just iterate through, well, Maybe I'll just make a new stone list. Why don't you just do that? Actually, you don't even need to make... You don't even need to actually make the stones. You might have to for part 2, but for the part 1, you really just need to know how many there are. Good point. Oh. Never mind. Yeah, you need to know what the actual stones are to apply those rules. So yeah, we have to kind of simulate it. So I'll just use like a linked list or something. Okay, so we're gonna blink 25 times. This should be our result. All right. Let's do it. So have our data. We have our data. What kind of Okay, so I have this already. Read row. And we're going to trim that. So we have our list of numbers. Let's check that thing. Day 11. We'll use a sample. Yep. That's what it was, right? Yeah. Okay, so now we're just going to loop through and apply those rules. So I'm going to make a new list here. Well, actually, let's just do this in a method. So blank num blanks and our stones. Blank. Well, let's do what am I going to call that method actually? Not blank. Yeah, I'll call it blank, whatever. Blank 25 times with our stones here. And I'll turn this into int. And first we're going to have, well, actually, 4. It's less than num blanks. Okay. So we're gonna make a list here for our new stones. And now we're just going to go through each stone. For each stone and stones. And then apply our rules. If that stone equals... Oh. No, this will be fine. Yeah, I don't even need to know an index. If stone equals 0, then we'll say new stones dot add 1. Else if, what is our other rules? If the stone has an even number of digits, so this is interesting. How would I? Yeah, you might as well just make a method for this. I think we'll just like 10, you can divide it by 10 2 times before it's 0. Divide by 10 once, divide by 10 another time is 0. But like 100, you divide it by 10, then it's 10 divided by 10, then it's 1 divided by 10. So if the number of times that you divide by 10 is even, while num is greater than 0, num divide equals 10 plus count, and then just return that, right? Else if has even number of digits, stone, we split it in half. Split digits in half. We're going to take a number here, and the I should actually return just call this num digits actually, because that's actually what I'm doing there. Num digits divided by 2 equals 0, because then I could actually use that right here. Num digits equals num digits num, and then you just want to like to get like the first half, it's just going to be num divided by num digits. Oh wait, yeah, num divided by num digits times 10. Wait, so like 1,000 has 4 digits in it. The number of digits is 4. So if I divide it by num digits divided by 2, which is 2 times 10, or 10 to the power of 2 is actually what I want. 10 to the power times 10 to the power of 2. Num digits times math.pal. Math.pal. Wait. It has to be 10 to the power of num digits divided by 2. Right? Like, so for 1,000, to get that 10 part, I'm going to divide it by 100, which is the number of digits divided by, or 10 to the power of the number of digits divided by 2, which is 10 to the power of 2. It's 100 divided by 100. And then, yeah, that's it. That gives me the first half. And just cast this to an integer. And the second half The second half, a little trickier. I mean, I could just use substring here, but second half. Second half. I could mod, so like 1023. 1023, if I mod that by 100, what is it? If I mod that by 100, don't I get 23? Oh, sorry, mod that by the first half times times this. So the first half is 10. If I multiply that times 100. Yeah, so if I mod that by this, what's the wait. What? Wait. So if I have like 1023, that's obviously going to get split up into 10 and 23. To get that 10, it's just going to be 1000 divided by 10 to the power 4 divided by 2. To get the second half, what is 1023 mod 1000? Is it 20? It's 23, right? Yeah, so just, or am I dumb? Why did I forget how like mod works all of a sudden? 13 mod 10. 3. Yeah, it's definitely, yeah. So just mod it. Mod the actual number by the first half. Oh, I'm sorry, the first half times this. I literally said that earlier. I remember saying that now. Mod the first half times this. And that should give you... let me call this something for now. I'll figure out what to call it. Okay. And then return first half, second half, and then halves equals split digits in half, stone, and then new stones dot add. Can I do add all with the halves? Can you do that? No. But I think you can do list.of or something. Nope. Oh, you can do that. Have 0. Halves 1. You can do it like that. And then the third rule. Oh yeah, else. Just multiply it by 2024. New stones dot add stone times 2024 Then at the end, just say stones equals new stones. And then at the end, you just return stones dot size. And that gives me the right answer. Am I going to overflow here? No, I shouldn't, because it's just going to be the size of the collection, which is int.max value. So yeah, let's do it with the real one. Boom. Oh, that's not the right answer. I could be overflowing. I think I definitely am overflowing inside of this collection here. Let's do that. Just use it everywhere. I can honestly make that generic. Oh, no, I can't. So I'll just make one just like it for long. It's fine. I'm gonna have to change this in a couple places. Read integers. Read longs. Okay. Yeah, I was overflowing or something. Sweet. Part 2, the historians sure are taking a long time. To be fair, the infinite corridors are very large. How many stones would you have after blinking 75 times? Oh, thank you. So easy. Part 2. $75 times. It's just gonna screw it up. It doesn't even give me a... Let's just see if we're right first try. Oh man. Oh man. Uh-oh. No. Is there a way to, like, do this faster? Oh, no. How long do you think this will go? Can I parallelize this? Let me think. No, you really can't. Because the next iteration depends on the previous. Each iteration depends on... Actually, you could do this in parts. You could do this in parts. If I split it in parts. Parallel, or... blink this half, blink this half, blink this half, blink this half. Yeah, you could turn this into login. Okay, so... yeah. The num blinks. Yeah, if you split it in half, you totally, yeah, you could totally do this in like log 2n, or log 2, log base 2n. Yeah. Well. Or you could like parallelize it, right? You want to try that? That seems unnecessary. Yeah, we're gonna do some. All right, so simple problem, just like a matter of like, how do we do it fast? I think I'm gonna parallelize and do like the halves. Like, blink this half, blink this half, blink this half, blink this half. Like, what would the base case be? Just like the. And I could just apply these rules here. If stones.size equals 1. Seems a little overkill, but and let's make and instead of doing this, we're going to return list dot of 1. Oh yeah. This will return a list of long. Return this. And this might, what the heck? This might be mad slow. Yeah. So if return apply rules. Oh. Yeah, just say stones.get 0 for now. Dot size. That's all we care about. Yeah. Otherwise, we're going to blink. Num blinks. Stones dot sublist 0 to stones dot size divided by 2, and then first half, second half equals. Can you take one argument with that? No. Stones dot size, and then return first half plus second half. Now this is going to be just as slow, right? See if this still works first. Oh, that does not work at all. Why doesn't that work? Copy all this. Junk. Oh, because I wasn't even... Was I using it? Yeah, I was using it. I didn't change anything else, right? Yeah, slow. Okay, what's up with that? Oh. Yeah, and each time you actually want... Maybe I would have this return a list of long, and instead of that, I would just return... I would return that, and then I'll say... It's gonna be super mega slow, I think, but maybe not. And then just say... I could just say, instead of this, I could just say first half dot add all. Now that's going to return, yeah, you don't even need this. and basically kind of the same thing. I just want to make sure I'm getting this right first. Oh. Oh. Oh, which one's immutable? I think list.of. Yeah. So. I think this is going to be like super slow, but I'm going to parallelize it in a second. I just need to make sure that this works. It's going to be slower than earlier, but it's the same, right? Yeah. Same answer. So now I want to parallelize this. So yeah, I'll parallelize. How will I parallelize this? Let's get rid of this for a minute. I gotta figure out how exactly, or what exactly I'm gonna parallelize. So each one of these guys could be performed on its own thread. Is that the best way? So I could turn this into a future. It would be like future list long first equals yeah, so make a executor service, executor service executor equals, so do that, and in here I'll just say executor equals, well, I can just have one for both for now. Executor new, or what do I say? Executor dot what is it? Executors, I think, is what I'm looking for. Dot new fixed thread pool, and then we'll use runtime dot get runtime dot available processors. I don't even know how many I have. Probably 4. And I have the executor, so the executor I need to add callables. So this is going to be executor dot submit new callable, or it's just going to be callable. It's like I need to make a callable in here, right? And it just needs a list of longs. What exactly? I forgot how to use executor service. Right here. That's right, callable. Here's your callable. And it's going to return a list. So it is going to be a callable. Do you like pass it any? How did I do this? Takes no arguments. So I can declare it in here, I guess. Callable. List of long. Callable equals. It's gonna be this. Oh, crap. What the heck? Okay. I don't know if that's gonna work. We're gonna see. Yeah, do the second half here. And then first half. Like that? Yeah. Wait, how do you like... Yeah, you could do that. Have a list of futures up here too. Future list. Long futures. And then down here just say futures.add executor, you know, whatever. Futures, oh. What? Oh, executors.submit. Executor.submit. First half. Executor.submit. Second half. Is this, is there an exception? No? What? What does this do? This returns a future. How's that? That's literally what it is. Huh? Huh. What? This should do it. This should add it. Executor.submit returns. Am I tripping about that? Should I do execute? What does execute return? It's definitely submit. Yeah, this returns a future. What is the problem here? Oh my gosh. This is this should be a list of future. That's what it was. Whoops. So I add those. So if I add each of those, I think that'll work. And then at the end, go through the futures and then count up the lengths. So I'll just turn this into a null, I mean a void. What? Oh, what? Wait. What if I did it right here? What if I did that? I don't think this is gonna work. This doesn't seem right. And this, what now, dude? Oh. I don't know about this. It's not faster, dude. Does it solve the sample though? I just want to know, is it like logically correct? So something is wrong here. You know what it is? It's never gonna finish if I do it in here. Yeah, I really want to do this currently. So, dang, part one was easy, huh? Yeah, you can't do that because this is a blocking call. That's what the problem is. If you don't know what's going on here, obviously I didn't either. Wasn't thinking. So I'm doing like recursion, and then within one of those call stacks, this is a blocking call, so it's never gonna finish. I mean, we could even see that if I do this. Oh, that time we... Oh, yeah. Still running. Anyway, gotta come up with something else here. How long would it take to run brute force? Probably a long time. I really want to do it concurrently. Yeah, what? I need a base case in there. I could do that if size equals 0. Just return. But when do the rules get applied? Right. Let me think about this for a second. So, cut it in half. I could parallelize each half. So why don't I start there? Why don't I just start there? Yeah, what if I just... What if I just split it into 2s first? What if I just did that? Alright, I'm gonna have to like Control Z a bunch of times. Yeah. Okay, that's the sample, right? Yeah, that's the sample. So what if I just put it into two thingies? the number of available processors. I'll just make a couple of futures. And I'll just split it in half. Let's do it in half first. Let's see how fast that is, if that's faster. First half. Stones dot sublist 0 to stones dot size divided by 2. Second half. It's gonna be this to the size. And then yeah, like, is this gonna be faster? Should be, I think. Oh. Well, of course that's not gonna be faster. You gotta make a future list long first future equals executor dot submit blink 25 first half. Do I have to like declare this? Oh, what? Oh, okay, so it's gonna be a list of integer then. Or just an integer. I mean, this should be twice as fast, right? First future dot get plus second future dot get. And I'll have to just state that that does an exception. And that's how that will look. Let's do that for part 2 also. And now let's see, that took about I let it run for 6 seconds. Oh. Why did it print it out twice? Do I have a print statement somewhere? What? How the heck did it print it out 2 times? It's still mad slow. I have to do it. Yeah, that's not gonna really make it faster. But I think if I did this in here, it might make it faster. Maybe. Let's try it. Oh, you know what? I guess that might work. That might be also mad slow. Try it like that. So you'll have a or why don't I just do a new linked list? Might be faster. And then for each stone, in stones, future oh, this will be a list of futures. And we'll say futures.add executor.submit apply rules to that stone. Yeah. And then at the end, for future list long future in futures new stones dot add all future dot get yeah. Oh, and I'm gonna have to return new stones. See if this works. I feel like this should be faster now. Not really, huh? What's the trick here? What's the trick then? Is it... I can't... I don't think they do any that must take this long. Come on, damn it. It's been going a whole minute. How can I do this quickly? Dude. I'm actually just gonna let it run. I'm just gonna let it run while I think about it. I gotta think about how to do this. I don't know if that's making it faster or not. I don't think it is. Yeah, because that's just, apply rules is O of 1, right? Yeah. Yeah, unfortunately, blinking, one blink itself, each blink anyway, each blink is not an independent task. So I can't just, you know, parallelize all the blinks because each blink depends on the previous blink. But you can parallelizing each individual stone's calculation, but that's not really gonna help me. It's not gonna help me at all. Actually, it's probably making it slower. Yeah, let's see. Yeah, I want to do... I feel like I'm missing something. I don't think you shouldn't have to know concurrency to do this. What's the trick? I'm missing something. Oh, you know what? Oh, actually I could parallelize. I could split the input array. What is the input anyway? Is it big? I don't even remember. It's not like huge, right? What if I split these up into their own little threads? That's not going to help much. For each one of those. Calculate all its blinks. That won't help much, I don't think. What if I split it up? Do a blink, split them up. Do a blink, split them up. I wonder how long this is going to run. Yeah, how long could this take? Obviously, I think I need to do this concurrently, man. If I did this... Mm-hmm. 6 minutes. Are there any problems that, like, is there like a... Like, I do problems from Project Euler. Project Euler is like a math... Yeah, a few seconds or less. Well, that's what freaking Gemini says. Yeah, there's gotta be... Is there a trick I'm missing? Where am I doing it right now? Where am I parallelizing? Right here. Oh, I ran out of space. Okay. I ran out of space, so something... So there has to be a better way to do this. I mean, you can do it in parts. I might do that. Well, it's 75 though. That's where I'm having issues. What if I did it in pieces? What? Stone. Oh, yeah, you don't want to do that. Stone equals new stones. Uh... Don't judge me yet. I ran out of space. It's still gonna be as slow though. Oh man. Oh, that is not right. That is not right at all. What happened here? Hmm? Oh. What the heck? Oh. You want to pass new stones in here. Well, now I'm not using stone. Oh, yeah. You can just say list out of in here. List out of. Stone. Oh, still running. Was that faster? I think it was the same. Shouldn't run out of memory this time, but this is still going to take more than 8 minutes or whatever. I got to think about this one. Is this supposed to take forever? Maybe this one's supposed to take a long time. I ran out of memory earlier though, man. Oh, crap. What if I parallelize it right here? I'm I'm just gonna brute force it, dude. Let's just let it run. We brute force. Oh my gosh, dude. gotta think about this one. See, I can't do that either because I've memory. I'm going to look up. I'm gonna look at YouTube real quick, and I'm gonna see, just to see how screwed up I am, if anybody has like already finished. I'm sure people have finished. I just want to see like how fast have they finished it. Jonathan Paulson finished it in 20 minutes.
Alright. Day 11, Advent of Code.
This guy's crazy, man.
Waved 25 times. Right?
Dude, this guy is so fast.
I see.
Oh, I ran out of memory. Dang it, dude. I ran out of memory. Again. Okay. So, something. Oh, dynamic programming. Why didn't I think of that? Do some dynamic programming. Yeah. Yeah, because it is going to kind of repeat itself. Yeah, dude. I'm so dumb sometimes. Alright. We're going to do a little dynamic programming here. We're going to map long to int. Oh wait, just do a hash map. And put if absent. Yeah, just put. It's gonna be put. Put stone to new stones dot size. Put the new stones dot size in there, and then if map.get or map.contains key stone, if it doesn't contain that key, and then let's try that. Zero. Oh. Are we stuck somewhere? What's going on? How come we're not printing out? How come we're not printing? No, that should be fine. Why is it not printing? Yeah, let's back up. Let's like back way up. Let's back way up. Oh. Yeah, even before this. Is this the original thing I had? Yeah. Okay. So let's use dynamic programming in here. And let's see, where are we going to do this? Yeah, you can't do it like that. You'll run out of memory. So you want to go through each stone. And then for each blink, wait. This is not gonna work. Hold on. Well, yeah, it would. Right? just make sure that works real quick. I think this should be the same. No. What? Oh, crap. Ugh. Okay, so now implement dynamic programming. So for each stone, let's map it to whatever that sum is going to be. Like that. What? It's gonna be mad slow. Let's give it a shot though. Let's try it out. Let's sort of let it run. Yeah. That's the right answer, right? 683. Yeah. So, I'm just gonna... This should work, I think. There should be a lot of, like, repeating sequences in there, I think. Let's, like, print out, like, where we are. For each stone, right? Let's print it out. Why are they printing out all at once like that? I think that's just something to do with Gradle. Oh, I don't think so. Wait. Okay, that's like the first... Is that the first one? In the... Okay, yeah, that's just the first one in day 11. Dang, just that one's taking forever. The next one won't take that long, though, because it's smaller. So I have to blink 75 times with that one. Blink 75 times. So this first one should take the longest. I guess not necessarily, huh? This one's ridiculous. Is there another opportunity I could check? Oh my gosh, I'm not even putting it in the map. I wasn't even putting it in the map. Now it should be faster. Hopefully. Now it's being like mad slow. Do I have something like orphaned? What? No, oh. What? No way. Obviously that's not right. There's no way. I know. I know it's too low. Why did it print out the same thing twice? I'm gonna have to clear... Or I'll just do this. Yeah, that's what it was. But that, I think that was a lot. That was way faster. Maybe. I can't think of anything better besides mapping each number to the size that it would be after, you know, however many blinks. I I think that's probably the way to go. I should print out the number of blinks too. I just want to know like how far along are we getting? My computer hates me right now. Oh man. It's not happening, bro. Oh my gosh. That is not cutting it. That's not gonna cut it, man. Dang, man. Okay, let's see. Yeah, what if I did... Alright. I'm going to pick up on this in the morning. Spent 2 hours